हेलो 46, क्या बात है बहुत जल्दी।
अरे सर, लैब अभी कंप्लीट हुई तो मैं फॉरेन ज्वाइंट हो गया।
क्या बात है। और बताओ क्या चल रहा है बेटा, कैसी तबीयत है।
सर, माइक्रो प्रोसेसर और माइक्रो कंट्रोलर की लैब थी ना आज। अच्छी
ओके
चल
ओके।
रही थी।
ओके ओके, गुड गुड। बढ़िया बढ़िया। आई होप माई स्क्रीन इज विजिबल टू यू। हेलो।
यस सर।
ओके ओके। Very good morning to all of you students. I hope my voice is audible and the screen is visible.
Good morning, sir.
The screen is not visible.
Yes, sir, screen is not visible.
Okay, so just wait a minute again. I hope now it is visible to all of you.
Yes, sir.
We have already studied what is Gyalakota model In this Gia-Coletta model, we were discussing about various parameters that were unknown to us. We started with the basic connection between the virtually present V dash and C. That connection was known as R V dash C. Now, in our figure number 3, we were discussing about diffusion capacitance, that is CE, and in common terms, it is known as CB dash E. This B dash represented the virtual presentation. In actual sense, it would be CBE. So it is written CBE or CE. Up till now, we have studied about this diffusion capacitance, Gia-Coletta model, hybrid pi CE model, and why we are going for hybrid pi model instead of H parameter models. Am I right? Am I wrong? Please respond.
Yes, sir.
Okay. So accordingly, now we are moving further, and now we are moving towards the transition capacitance. Please note down in figure number 3, I have mentioned transition capacitance as CC. Basically, it is CB dash C or commonly known as CC, C subscript C. Please write down the definition of transition capacitance. Can I start? Hello, students.
Just a second, sir. Yes, sir. You can.
When PN junction diode is reverse biased, that is, capacitive effect is being seen. When PN junction diode is reverse biased, a capacitive effect is being seen, and that capacitive effect is known as transition capacitance. That capacitive effect is known as transition capacitance. It is due to reverse bias of PN junction. So this capacitive effect of reverse bias is in CB junction. I repeat, it is in CB junction and is referred as CB-C or CC. Okay, can I move further? Dear students, can I move further?
Yes, sir. Yes, sir.
Yes, sir.
The physical resistance, the physical resistance between external base terminal B and internal node B dash. The physical resistance between external base terminal B and internal node B dash is termed as RB dash B, as you can see in figure number 2. RB dash B or RBB dash, that is the physical resistance between the virtual B dash and actual B. I hope it is seen in the circuit also. In figure number 2, that is over here, the physical resistance between B and B dash. This is known as RB dash B. Physical resistance between virtual base and actual base. Hello students, I think I'm audible, screen is visible. Can I proceed further in explaining this term?
Yes, sir.
So this RB dash B is commonly known as spreading resistance. Spreading resistance. Tirth Makadia, is it possible for you to kindly mute yourself? Thank you, Tirth. So we were talking about RB dash B, that is known as a spreading resistance. It is between the external base and internal node B. Can I proceed further?
Yes, sir.
Okay. So all of you are requested to kindly draw this particular figure. That is figure number 4. It can also be represented as figure number 2A because it is part of figure number 2 only. So kindly refer it as figure number 2A. Please draw this T model. This is a T model, sort of. So we will be discussing about it because we have already discussed about RB dash B. Now we will start with RB dash E. So students, I hope you have drawn the 3 resistors. Now I'm going to start with RB dash E. The resistance connected between BE and collector junction, base emitter and collector junction in series. I repeat, the resistance connected between base emitter and collector junction in series. A virtual base, which is B dash, for the junction capacitance is to be connected to instead of B. 2 instead of B is known as RB dash E. So basically this node is not B, it is B dash. So this is known as virtual base connection to the junction capacitance is known as RB dash E. I hope you have written. Can I proceed? Please let me know.
Sir, can you repeat the last point, B dash from the junction?
See, this is B dash point, height. This
Yes.
point is B dash, this point is E. So the resistance between this virtual base and this junction capacitance is known as RB dash E.
Okay, okay, sir.
Okay. So it is just the jumbling of the words, nothing else. Slowly and slowly the strength of the students is increasing. That is nice because they are assuming that 1:40 से 11:40 से ऐसे थोपन चालसे 11:30 ના લેક્ચરમાં વાંધો નહીં. It's up to you when you want to join because it is you who are studying, not me. So students, now we are proceeding for the next term, which is known as RCE, which is known as RCE. RCE is basically output resistance due to early effect. RCE is output resistance due to early effect. So guys, up till now we have studied these terminologies. I hope all the terminologies written in blue letters are being seen to you all. If you are having any doubts, please let me know.
No, sir, no doubt.
Okay, so now I am having a doubt. I would start with what happens when there is a constant voltage VCE to the transconductance. What is transconductance? Hello students. Hello. I hope I'm audible up till now. So I am being audible now also.
Yes, sir, you are audible.
So nice of you, Yesha. So Yesha, what is transconductance? Yes, Himanshu, what is transconductance? Hello, Himanshu. Okay, fine. Uh, Hari Joshi, enrollment number 9. Hello, Hari.
Yes, yes, sir.
Sir, what is transconductance? Chalo, what is resistance?
Hmm?
What is resistance? Resistance એટલે શું બેટા?
Distance.
ઓહ્મ્સ લો વાંચ્યો છે ને? ફોર્મ્યુલા ખબર હતી?
Yes, yes, sir.
શું છે ઓહ્મ્સ લો? R is equal to
So V by I.
V by I.
ના.
અને એ હા બરાબર છે V by I. ગભરાવશો નહીં. હવે મને કહો reverse of resistance is
So resistance is
1 upon R ને આપણે શું કહીએ છીએ?
conductance.
હા conductance કહીએ છીએ. તો conductance નું ફોર્મ્યુલા શું થઈ જશે?
1 upon R by V.
1 upon R by V. વાહ
1 upon R equal to I by V.
I by V. વેરી ગુડ. તો હવે આપણે આ સર્કિટમાં ટ્રાન્સ કન્ડક્ટન્સ એટલે સીઈ ના કેસમાં આપણે આઉટપુટ શું છે અને ઇનપુટ શું છે? આઉટપુટ કરંટની વેલ્યુ ફોર્મ્યુલા શું છે? આઉટપુટ કરંટનું વેલ્યુ શું છે? એટલે નોટેશન શું છે આઉટપુટ કરંટનું સીઈ માં? કોમન એમીટર ના કેસમાં આઉટપુટ કરંટ શું છે બેટા? કઈ વસ્તુ ગ્રાઉન્ડ છે, કઈ વસ્તુ આઉટપુટમાં છે, કઈ વસ્તુ ઇનપુટમાં છે સીઈ માં?
આઉટપુટ એમીટર અને ઇનપુટ
બેટા એમીટર ગ્રાઉન્ડ છે ને, સીઈ છે, કોમન એમીટર કન્ફિગરેશન છે, ગ્રાઉન્ડ છે,
કલેક્ટર
આઉટપુટ છે બરાબર. તો કરંટ કરંટ ક્યાંમાંથી નીકળશે? કલેક્ટર માંથી નીકળશે. તો આઈસી ઇઝ આઉટપુટ કરંટ. 9 નંબર બેટા બહુ અવાજ આવે છે ઘેરથી. થોડુંક ટ્રાય કરો ને યાર, લેક્ચરમાં તો મગજમારી ના કરશો ને પ્લીઝ.
સર
કલેક્ટર કરંટ છે રાઈટ?
હા.
હવે ઇનપુટ વોલ્ટેજ શું છે?
ઇનપુટ બેઝ
હા બેઝ અને એમીટર ના વીબીઈ.
પીબીઈ.
મેં કાલે જ લેક્ચરમાં લખાયો, પરમ દિવસે લેક્ચરમાં લખાયો હતો. ટ્રાન્સ કન્ડક્ટન્સ ઇઝ ડિનોટેડ બાય જીએમ. ફોર્મ્યુલા છે ચેન્જ ઇન આઉટપુટ કરંટ ડિવાઇડેડ બાય ચેન્જ ઇન ઇનપુટ વોલ્ટેજ. જો લખેલો છે અહીંયા GM it is equal to delta IC upon delta VB dash E. બરાબર હરી?
હા.
હા તો લખો all of you at constant VCE. At constant VCE this is the transconductance. So guys, am I clear? I hope you have written all the formulas, you have written all the definitions, you have written all the parameters of Guy-Coletta model. So this Guy-Coletta model or Guy-Coletta model comprises of this particular thing, which is nothing but a hybrid pi model, which comprises of RBB dash. So Hari, what is RBB dash beta? BB dash. Enrollment number 9, what is RBB dash known as?
આરબીબી ડેશ
હમણાં લખ્યો છે તમે આરબીબી ડેશ ને શું કહીએ છીએ આપણા Guy-Coletta મોડેલમાં? સરસ, વેરી ગુડ. બોલો બેટા. હેલો
યસ
બેટા બોલો, આરબીબી ડેશ એટલે શું છે?
જીએમ.
વેરી ગુડ. I think Utsav is there. Utsav?
Yes, sir.
હા બેટા કેવું છે?
Spreading resistance.
Spreading resistance, very good. So RBB dash is known as spreading resistance. સરસ. હવે બેટા ગિયા કોલેટા મોડેલમાં સેકન્ડ છે RB-E. RB-E એટલે
resistor connected between base emitter and collector junction in series.
વર્ચ્યુઅલ બેઝ એન્ડ જંક્શન કેપેસિટરના વચ્ચે. વેરી ગુડ બેટા. વેરી વેરી ગુડ. હવે બેટા CB-C શું છે? CB-C. B-C.
Diffusion capacitance.
ના બેટા CB-E છે ના that is diffusion capacitance. CB-C છે that is transition capacitance.
Yes, sir.
Okay.
Yes,
Chalo,
sir.
okay, very good. Now we are moving towards hybrid pi conductance. Hybrid pi conductance. All of you are requested to draw this diagram, figure number 4. This particular diagram, not the above one, the below one. This diagram. Diagram draw કરીને મને હા પાડજો, unmute કરીને.
Done, sir.
Sir, done.
Okay, thank you. So now guys, according to figure number 4, what we are going to do is please see that we already know IC it is equal to ICO minus alpha IE. ये ICO अल्फा और IE क्या है ये आपको ऑलरेडी पता है. अल्फा जो है वो करंट गेन है, ICO है जो है वो बैक प्रोपोगेशन का करंट है, कलेक्टर करंट है रिवर्स सैचुरेशन में. IE is the emitter current and IC is the output current. Basically IC is equal to ICO minus alpha IE. According to this circuit, ICO is constant. So we can say that any change in the output current, any change in the collector current is directly or indirectly related with alpha IE with a negative sign. So delta IC is equal to minus alpha into delta IE. I hope you are writing the two equations. Now, we already know that GM, that is trans conductance, is nothing but delta IC upon delta VB dash E. Delta VB dash E when VCE is constant. When VCE is constant. So, જે delta IC છે, this delta IC. This delta IC is nothing but this delta IC. So, I can replace this term over here. Yes or no?
Yes, sir.
Yes, sir.
So kindly replace this term over here and find me the new GM. What is the value of new GM? Shriji, enrollment number 49. Beta, what is the value of new GM? What is the value of new GM?
Sir, IC upon VB dash E.
बेटा आईसी की वैल्यू अभी आपको रखनी है, आपने रखी नहीं, यहां से ये वैल्यू यहां पर रखोगे तो क्या हो जाएगा? ये डेल्टा आईसी है, ये भी डेल्टा आईसी है ना, चेंज है।
Delta I upon delta VB dash E.
Hello 47, am I audible?
Yes, sir.
The delta IC, if I replace it by minus alpha delta IE, so what will
Yes.
be my new GM?
Minus alpha delta IC by delta V dash E.
Okay, delta IE, not IC.
Yes.
See. Now, I have removed the negative sign because the negative sign is the representation of a PNP transistor, whereas in case of a NPN transistor, it would be plus. It would be plus. Secondly, VB dash E. VB dash E can be taken as VE. Can be taken as VE. So the new formula for GM, that is transconducting, is alpha delta IE upon delta VE. I hope you are understanding it.
Yes, sir.
Yes, sir.
I repeat again, the negative sign is being removed because we were having PNP transistor over here. In case of a NPN transistor, it is directly equal to VE. So, the new formula is something like this. That is RE is equal to, we know that RE, that is emitter resistance, would be equal to the emitter voltage divided by emitter current. So RE is delta VE upon delta IE, and 1 upon RE would be equal to delta IE upon delta VE. Hence, the relation between transconductance and emitter resistance would be something like this. GM it is equal to alpha upon RE. I hope the equation is visible to all of you and you have written the formula of 1 upon RE so that it would make you comfortable in writing GM. Once you note down the formula, please let me know so that I can proceed further.
Done, sir.
Done, sir.
Now please note down. Emitter diode is forward biased diode. Emitter diode is forward biased, and RE is equal to this, and RE is equal to this, where VT is our Boltzmann constant. VT is our Boltzmann constant. Anyone has any idea what is the value of Boltzmann constant K? Or the value of VT? Any one of you?
Sir, 1.38 into 10 to the power minus 23.
Yes, correct. Boltzmann constant, the value of K is 1.38 into 10 to the power of minus 23 joules per degree Kelvin. So guys, now I am replacing my RE with this. The formula is GM is equal to alpha upon RE. Replace RE with VT upon IE. Please do the needful. Once you have done it, let me know. So what is my new GM now? Hello students, what is my new GM now?
Alpha IE upon VT.
Very good. Alpha IE upon VT. And what is IE equal to? Hello? Hello students. What is IE equal to?
GM into VT divided by alpha.
નહીં હેત આપણે જ્યાંથી ચાલુ કર્યો હતો ને ત્યાંથી કહું છું IC is equal to ICO minus alpha IE હતું. હેલો.
Yes, yes.
Yes, sir.
Yes, sir.
તો આપણે ત્યાંથી જ લઈશું આ ઇક્વેશન. Now we are moving towards the total final value of transconductance, that is GM. Please note down, in case of PNP transistor, IC is negative, whereas in case of NPN transistor, IC is positive. Because you know that in case of PNP, the movement of holes and electrons change as compared to NPN. So IC is negative in PNP, whereas it is positive in NPN. Therefore, in the present case, VE is equal to VB dash E, that we have already written in the above equations. VE is equal to VB dash E. So as a result of which, what I can do is I can write, since IC, see this is changing now. So GM is equal to IC minus ICO upon VT. Are you able to understand this particular change?
Yes, sir.
So I mean to say that in any of the case, whether it's a PNP transistor or NPN transistor, we will take our GM to be positive. Now, if GM is positive, because IC is very, very larger than ICO. Why? ICO is nothing but reverse saturation collector current. So reverse saturation collector current has to be very, very small as compared to collector current in case of CE amplifier. So IC is very, very larger than ICO. Hence GM is positive. So I can neglect ICO. The final formula would be ICQ divided by KT, because I have replaced the value of Boltzmann constants. VT is equal to this. Hence it is this. Now, what is the value of Q? What is the value of Q, beta?
6.23 into 10 to the power minus 19.
1.6 into 10 to the power of minus 9.
Yes, sir. Sorry, sir.
होता है कोई बात नहीं. K is equal to 1.6 into 10 to the power of minus 19, that is Q, and at room temperature, that is at 300 Kelvin. Let us calculate our GM. Please do the needful, beta. So this is the formula of GM. All of you are requested to kindly note down this formula so that we can proceed further. In case of any doubts or queries, please let me know. हमने K की वैल्यू अनुभव एनरोलमेंट नंबर 15 ने थोड़ी देर पहले बताई थी, that is 1.38 into 10 to the power of minus 23. Q की वैल्यू आपको पता है, that is 1.6 into 10 to the power of minus 19. हम लोगों ने ये दोनों वैल्यूज रख दी हैं, तो ये फॉर्मूला बना है. अब हम लोग 300 केल्विन पे GM को कैलकुलेट कर रहे हैं. तो फाइनल फॉर्मूला इज लाइक दिस. एनी डाउट्स इन इट, प्लीज लेट मी नो. Hello students, I hope I'm audible, screen is visible, you are able to understand how to put the values and how to calculate it. In case you are not able to understand, please let me know right now. जानवी बेटा समझ में आया?
Yes, sir.
सृष्टि, विधि, ऋतु,
Yes, sir.
Yes, sir.
मुआज,
Yes, sir.
59.
Yes, sir.
Okay, that's great if you're able to understand. So I hope Utkarsh and Dharmik આ બધાને પણ ખબર પડી ગઈ હશે. Can I proceed?
Yes. Yes, sir.
Okay, that's nice of you. So our next thing is input conductance. Our next thing is input conductance. So please draw the formula. Please, draw the circuit for input conductance. This is hybrid pi model, and then we will be proceeding for H parameter model of the same. So you can just note it down, both the figures. We are now first we calculated Gm, now we are calculating Gb dash E. So for calculation of Gb dash E, kindly note down both the circuits.
Done, sir.
Done, sir.
Okay, students, just wait for 1 more minute so that the other students can just note it down. ફર્સ્ટ યર કોનો એને પૂછવું પડશે. Yes, students. So I'm proceeding further. Now, what have you noted in both the figures? Please let me know. In figure number 5 and figure number 5A and B, what have you noted? Hello, students. What have you noted? Please let me know. Yesha,
Yes, sir. So, like
note किया.
R B B dash, then I B V B dash E R B dash C R B dash E G
बेटा
H.
ये तो आप मुझे टर्मिनोलॉजीज बोल रहे हो जहाँ पर ड्रॉ की हुई है.
हाँ.
ऐसा नया है इस सर्किट में.
Sorry, sir.
What is new in the circuit? What is new? See, I have written in both the circuits. It is hybrid pi model and H parameter model for CE, right?
Yes.
But as you can see, both the circuits are in low frequency.
Yes, sir.
So even though they are at low frequency, there is no capacitor.
Yes.
Right? So from figure number B, calculate IC. What is IC is equal to? चलो करो. IC का फॉर्मूला बताओ मुझे. हेत મને IC નો ફોર્મ્યુલા કે ના બેટા.
Yes, sir. Hello.
Formula for IC. Formula for IC.
Sir,
From
ICO
figure
minus
5B.
alpha,
What?
ICO minus alpha IE.
બેટા આપણા પેલા ફિગર માંથી નીકળી જાઓ બહાર. હવે આપણે નેક્સ્ટ ટોપિક ઉપર આવી ગયા છીએ. Now we are not calculating GM, we are calculating GB dash E. So it is altogether a new formula. So I am calculating, we are applying KCL in figure number 5B. Apply KCL in figure number 5B. So what is IC equals to? So students, can I start 8? What is IC now?
Sir, it can be VC upon HOE.
Beta, what is IC in case of a CE amplifier? It is out collector current.
Yes.
So in the given circuit of 5B, what is in the output side? In the output side, we are having this thing, this full thing, right?
Yes, sir. So
So
VC.
yes, so what V is IC is equal to HFEIB plus HOEVCE.
Yes.
Okay. So whatever is current, that is because of this current source is there, right? So this current source multiplied by whatever is the resistance and the voltage. Okay. So my IC is equal to this. Okay. We have applied KCL on figure number 5B, and hence IC is equal to this. Any doubts in this circuit, in this equation? Please let me know.
No, sir, no doubt.
Okay, now please calculate current gain if my output is short circuited. My output is short circuited, so calculate the current gain. What is HF equals to? From this equation number 1. Output is short circuited, so what is HF equals to? Enrollment number 13.
Yes, sir.
બેટા આઉટપુટ શોર્ટ સર્કિટ કરેલો છે તો
Sir,
HFE શું થશે આ ફોર્મ્યુલા
IC upon
પ્રમાણે
IB.
yes IC upon IB very good. So now HFE is IC upon IB. Guys, you are kindly requested to please mark the equations as it is written, because at a later stage these equation numbers would be utilized. These equation numbers would be utilized. So now I go back to figure number 5A. I go back to figure number 5A. So according to figure number 5A, IB is flowing into RB dash E. I repeat, IB is flowing into RB dash E. This is being flowing like this. Yes or no?
Yes, sir.
So what is VB dash E? What is this value equals to? What is this value? What is the formula for VB dash E? If IB is flowing like this, so what is VB dash equals to? Hello? Enrollment number 47.
Yes, sir.
Beta, what is Ohm's law?
V equals to IR.
V equals to IR. So આપણે છે ને અહીંયા V મેજર કરીએ છે. કરંટ કેટલો ફ્લો થાય છે અહીંયા? કયો કરંટ વેલ્યુ કઈ છે કરંટની?
IC.
અહીંયા IC છે. શું લખેલો છે?
IB.
અને રેઝિસ્ટન્સ કેટલો છે?
RB dash E.
તો આની વેલ્યુ કેટલી થઈ ગઈ?
IB upon RB dash E.
Upon V is equal to I into R નથી?
Yes, sorry, sir. IB into RB dash E.
ઓકે, હવે આ જે રેઝિસ્ટન્સ છે, આ બહુ વધારે છે. આ બહુ વધારે છે. ઓકે, આઉટપુટ કરંટ શું થશે? IC.
Yes.
So આઉટપુટ કરંટ IC છે, તો આ કરંટની વેલ્યુ કેટલી થશે? આની વેલ્યુ કેટલી છે?
VB dash E.
GM.
Yes.
Okay. So now IB is flowing into RB dash E. RB dash C is very large. Hence we are getting these two equations. Now as you can see, we are writing IC, it is equal to GM into VB dash E. What is VB dash E equals to? 46. VB dash E equals to? Hello, 46.
Yes, sir.
बेटा VB dash E equals to क्या है?
सर
अब ये लिखा है ना वी बी डैश इक्वल टू क्या है बोलो, ये क्या,
IC अपॉन GM,
ये आईसी लिखा हुआ है यहाँ पे,
सर IB इंटू RB डैश E।
ये फॉर्मूला मुझे यहाँ पर रखना है इस इक्वेशन में, नीचे वाली इक्वेशन में रख सकते
यस
हो,
सर,
रखो,
यस सर।
इसी कैलकुलेट करो। So students, based on this, please calculate IC upon IB. Please calculate IC upon IB and mark it as equation number 4. Mark it as equation number 4. Calculate IC upon IB. क्या आया आंसर मुझे बताना। 46।
सर GM इंटू RB डैश E और HFE विच इज इक्वल टू GM इंटू RB डैश E।
Very good. अबे बेटा, very good. So whatever 46 has just told, it is basically something like this, right? So now what we are having is, we are having this thing, that is IC upon IB, it is equal to GM into RB dash E, which is nothing but HFE. So if I want to calculate RB dash E from this equation, so I can say that RB dash E is equal to HFE upon GM. Yes or no? Yes or no?
Yes, sir.
Now this is RB dash E. So 1 upon RB dash E would be equal to GM upon HFE. I repeat, 1 upon RB dash E would be, इसका मैंने रिवर्स ले लिया तो क्या होगा वो GM upon HFE हो जाएगा, इक्वेशन नंबर।
Yes, sir.
Yeah. So now I am calculating this. ये हो गया, ये समझ में आया सबको? प्लीज यस और या नो बोलो, नहीं आया तो मैं समझाऊंगा वापस।
Yes, sir. Got it.
Yes, sir.
Yes, sir.
Okay.
Yes.
Now we already know GM is equal to IC upon VT. GM is equal to IC upon VT. Put this thing over here. Put this thing in equation number 7. Put this thing in equation number 7. So what is GB dash E now? What is GB dash E? Hello students.
IC upon VT HFE.
Yes, IC upon VT into HFE. So beta, आज ये equation તમે કહો છો, this equation is this, right? Yes or no? Are you
Yes.
on this
Yes,
equation?
sir.
Yes,
So
sir.
what? So we required to calculate GB dash E. That was our aim. Our aim was to calculate this thing, GB dash E. So based on this, what we can say that RB dash E is directly proportional to temperature and inversely proportional to collector current. I repeat, RB dash E is directly proportional to temperature and inversely proportional to collector current. Yes or no?
Yes,
Yes,
sir.
sir.
Yes, sir.
So that is the final conclusion from GB dash E, that RB dash E is directly proportional to temperature and this RB dash E is inversely proportional to collector current. Is inversely proportional to collector current. So students, that's all for today's class. In case of any doubts or queries, please feel free to ask me.
No,
Just
sir. No
wait,
doubt.
take the attendance, then you would be free to go. Okay. So thank you guys. Now you may leave.
Thank you, sir.
Okay.
you, sir.
Thank you. Thank you.
Thank you, sir.
Thank you.
Thank you.